Okay, so you sent us this research paper all about AI writing code.
Yeah.
And the title is a mouthful, CODESIM. Multi-agent code generation and problem solving through simulation-driven planning and debugging.
Right.
Get ready, though, because this is where it gets really interesting.
Hmm.
It describes this new system called CODESIM, and it's designed to be better at writing code than those AI systems that came before.
Yeah.
Now, maybe you're wondering, like, what makes this system so special? Why
Right.
should I even care an AI can write code? Well, get this. It learns a lot like you do.
What's so fascinating about this paper is that it tackles this fundamental problem.
Oh, yeah.
Current AI models, they often struggle to write code that's, completely correct
Right.
on the first try.
Oh, so they mess up, just
Yep.
like we do.
Yeah, they need debugging.
That's kind of comforting, actually.
Yeah, and refining just like us when we're learning.
Okay, but how does CODESIM improve on that?
Well, CODESIM uses this really clever multi-agent approach,
Okay.
mimicking how a human programmer might solve a problem.
So unpack that a little bit for me.
Sure.
What do you mean by agents?
Think of them as specialized AI modules.
Okay.
There's a planning agent, a coding agent, and a debugging agent,
Okay.
each with a specific role
Right.
in a whole process.
So one agent maps out the plan, another one writes the code, and then a third one checks for errors.
Precisely.
Okay.
But here's where it gets really interesting.
Okay.
CODESIM uses simulation.
Okay.
Just like you might sketch out a plan or visualize how an algorithm works before you actually write any code.
Hold on. So it's like running the code in its head
Yeah.
before actually writing it?
In a way, yeah.
That's wild.
CODESIM simulates how the code would behave
Right.
to both check the plan and to debug any errors.
So it's like double checking its work
Yeah.
before it actually commits to it?
Uh-huh.
That is clever. So tell me more about how this simulation thing works in practice.
The paper gives this great example with the Fibonacci sequence problem.
Fibonacci sequence?
Yeah.
Okay, remind me what that is again?
It's a sequence where each number is the sum of the three preceding ones.
Okay.
So it starts 1, 1, 1,
Okay.
then 3 because 1 plus 1 plus 1 is 3,
Got it.
then 5 because 1 plus 1 plus 3 is 5,
Right. I remember now.
and so on.
Okay, back to CODESIM then.
So when CODESIM tackled this problem,
Okay.
it created a plan with its planning agent.
Right.
But when it simulated the plan's execution, it revealed a flaw.
Oh, really?
The simulation showed that the plan didn't correctly handle the first number's initialization and calculation.
Uh-huh. So the simulation acted like a safety net,
Right.
catching the bug
Yes.
before any code was even written?
Exactly.
That's like when I work through a problem mentally to check my logic before I even start coding.
Precisely.
Yeah.
That's a key takeaway.
Okay.
This simulation-driven approach is what makes CODESIM so smart.
Right.
It's not just spitting out code, it's actually thinking through the problem, verifying its logic,
Yeah.
just like a human programmer would.
It's really thinking. Okay, so we've seen how simulation helps with the planning.
Yeah.
But the paper also talked about debugging.
Right.
Does CODESIM use simulation for that too?
It does.
Really?
And it's equally fascinating.
Okay.
Let's look at another example from the paper.
Okay.
Imagine you need to write a function that takes two numbers
Okay.
and then returns a list of all the even digits between them in ascending order.
Sounds pretty straightforward.
Yeah.
What happened?
CODESIM generated the code based on its plan.
Okay.
But when they tested it, it failed on a specific test case.
Oh, no.
It was supposed to return an empty list for the input 10 and 14,
Right.
but it returned a list containing 10, 12, and 14.
Ah, I see. So it looked for even numbers between 10 and 14.
Yeah.
But included the numbers themselves?
Right.
Even though their digits weren't all within that range.
Exactly.
Gotcha.
This is where the debugging agent steps in.
Okay.
Like before it simulates the code's execution,
Okay.
but this time it focuses on the failed test case.
So it's like, okay, let's rewind and see exactly where things went wrong.
Precisely.
Okay.
By simulating step by step.
Right.
The debugging agent pinpoints the error.
Okay.
It realized that the code wasn't checking if each individual digit was within the specified range.
Makes sense. Yeah. How did it fix it?
It added this extra step to check each digit within each number,
Okay.
ensuring that each was even and fell within the given range before being added to the list.
So again, the simulation allowed CODESIM to really see the problem. It's like it has an internal debugger running as the code is being written.
That's a great way to put it.
Yeah.
This simulation-driven debugging is what sets CODESIM apart.
Right.
It's not just trial and error.
Right.
We're using external tools.
Yeah.
It's using this more intelligent, human-like approach
Right.
to find and fix errors.
So this is all very impressive, but the million-dollar question is,
Yeah.
how well does it actually perform?
Right.
Does all this fancy simulation lead to better results?
That's where it gets even more exciting.
Oh.
The paper shows that CODESIM achieves state-of-the-art results on these various programming benchmarks,
Oh, wow.
even outperforming other more complex systems, sometimes by a large margin.
So it's not just a one-hit wonder.
No.
They tested it on all kinds of tasks,
Yeah.
from basic problems to complex competitive programming challenges,
Yeah,
and it consistently performed at the top.
right.
It really seems like they're onto something special
It does.
with this system.
What fascinates me is how this system mirrors human cognitive processes.
Yeah.
It suggests that for AI to truly master these complex tasks, like programming,
Right.
it might need to develop more human-like ways of thinking and problem-solving.
You know, that makes me wonder if this approach isn't just limited to code.
Right.
Could we use simulation to teach AI how to write stories or compose music or even design scientific experiments?
Yeah.
The possibilities are truly endless.
They are.
We've only just scratched the surface here. It's amazing to think about all the possibilities if we could teach AI to simulate and learn like humans.
It is.
But before we get too ahead of ourselves, let's
Right.
zoom back in on CODESIM.
Okay.
The paper mentioned that it was tested on different programming benchmarks.
Yes, that's right. And that testing is key for understanding how well it handles these, different kinds of programming problems.
Right.
They use human evil.
Human evil, so it's like a bunch of coding challenges that humans would typically solve.
Exactly. It's designed to test a model's ability to understand instructions in plain language
Okay,
and translate those into working code.
gotcha. And how did CODESIM do?
It performed exceptionally well,
Oh, yeah.
achieving a pass rate over 95%.
95%. That's insanely good. Is it basically as good as a human programmer on those tasks?
On these specific tasks, you could say that.
Wow.
And keep in mind, these aren't, easy tasks. We're talking writing functions to manipulate strings,
Right.
perform calculations, solve logical puzzles.
So it's not just regurgitating pre-written code snippets, it's
Yeah.
actually understanding the problem and coming up with new solutions.
Exactly.
That's pretty mind-blowing.
It is. And they didn't stop there.
Oh.
They also tested CODESIM on MBPP.
MBPP.
Yeah.
Okay, so now we're cranking up the difficulty.
They are.
What kind of problems are we talking about?
Think sorting algorithms, searching algorithms, even problems that use dynamic programming,
Wow.
which is, a pretty advanced technique.
Right, so like the kind of stuff you'd see in a computer science course or a coding interview?
Exactly.
Okay, and how did CODESIM do on those?
It performed admirably,
Okay.
achieving a pass rate over 90%,
Wow.
which is significantly higher than other state-of-the-art systems.
So it's not a one-trick pony.
Nope,
It can handle both basic coding and more complex algorithmic challenges.
it can.
It really seems like this approach using simulation and multi-agent collaboration
Yeah.
could be a game changer in AI code generation.
I agree. It's very compelling research, and it has implications far beyond just automating coding tasks.
Right.
This could lead to AI that designs new algorithms,
Wow.
optimizes existing code, even helps develop completely new software.
The possibilities are really exciting. It makes you wonder if AI can learn to code this. Well, what other complex human skills could we teach it?
That's the big question.
Yeah.
Could we apply similar techniques to music composition writing or even scientific discovery?
It's mind-boggling to think about.
It is.
But before we disappear down that rabbit hole,
Right.
I do have one more question about CODESIM. The paper mentioned it's open source.
Yes, and that's fantastic news for the research community.
Oh, why is that?
It means that anyone can access the code,
Okay.
build upon this work experiment with different architectures, explore new application.
So it's all about democratizing access to AI.
Exactly, which is something we're very passionate about.
Absolutely.
Open source really helps accelerate progress in the field, especially one moving as fast as AI.
Right. And speaking of progress, what are some potential future directions for CODESIM or for AI code generation in general?
Sure.
Where do you see this technology heading?
One exciting area is developing more specialized code generation models.
Okay.
Right now, CODESIM's pretty versatile,
Right.
but imagine AI systems specifically trained to generate code for, certain domains like web development,
Right.
data science, or even game development.
So instead of like one general AI programmer,
Right.
we could have specialized AI experts
Yes,
in different coding areas, almost like an AI team of coding specialists at
exactly.
your fingertips.
This could lead to more efficient and robust code generation tailored to specific needs.
That makes sense.
Another exciting area is integrating AI code generation with other AI tools,
Okay.
like natural language processing and machine learning.
So you could describe a problem in plain English.
Yeah,
And the AI would write the code and train a machine learning model based on your data.
precisely this could revolutionize software development, making it more accessible to people without coding expertise.
Wow.
and speeding up the development of AI-powered applications.
It's almost like the line between coding and problem solving would blur.
Right.
You wouldn't need to know how to write code, just be able to explain the problem you're trying to solve.
Yeah,
It's both exciting and a little daunting to think about all the possibilities.
it is.
One thing's for sure, the future of AI and coding is going to be incredibly interesting.
It is, and that's why research like this is so important.
Yeah.
It's not just about automating tasks.
Right.
It's about expanding what's possible and paving the way for a future where AI and humans collaborate
Yeah.
to create amazing things.
I couldn't agree more. You mentioned earlier that CODESIM is open source.
Yes,
So anyone can access and experiment with it.
they can.
If you're curious about AI and coding, I definitely encourage you to check it out.
It's a great way to get hands-on experience with cutting-edge AI technology.
We'll include a link to the CODESIM repository in the show notes.
We will.
Now, before we wrap up this deep dive, I have one final, slightly more philosophical question.
I'm all ears.
This whole discussion about AI learning to code like humans,
Yeah.
it raises questions about the nature of intelligence.
It does.
If AI can write code, debug, even come up with new solutions,
Right.
is it fair to say that it's displaying some form of intelligence?
That's a question philosophers and AI researchers have been grappling with for decades.
Yeah,
And there's no easy answer.
right,
But it's important to remember that intelligence is multifaceted.
right.
Just because an AI can perform a task that we associate with human intelligence, like coding,
Yeah,
doesn't necessarily mean it's thinking or understanding in the way that we do.
right. It could just be really good at following instructions
Yeah,
and manipulating symbols without any real comprehension.
that's one possibility.
Right.
But another is that as AI systems become more sophisticated and capable,
Yeah.
they might develop their own unique forms of intelligence,
Okay.
perhaps even forms that we can't fully grasp or understand.
That's both fascinating and a bit unnerving.
It is.
It's important to approach these advancements with both curiosity and caution.
I agree.
AI has the potential to be an incredibly powerful tool for good,
Right.
but we need to be mindful of the ethical implications
Uh-huh.
and ensure that its development aligns with our values and goals as a society.
Well said.
And on that note, I think we're ready for part 3 of our deep dive. Welcome back to our deep dive into CODESIM.
Yeah.
So before we doze into those philosophical depths,
Right.
we were talking about its performance on benchmarks.
Yes.
It's clearly a major leap forward, but I'm curious,
Yeah.
how does it actually pull this off? Like, what's under the hood?
One of the most interesting things about CODESIM is its use of open source LLMs.
Okay.
Those large language models that give it its reasoning power.
So it's not relying on those giant proprietary models that most researchers can't even get their hands on.
Exactly. They specifically tested it using models like Gemma, Mixtral, and Llama.
Okay, I've definitely heard of those.
Yeah.
What's the advantage of using those open source models?
Well, it makes the research more accessible and reproducible.
Okay,
Anyone can download these models and run their own experiments.
gotcha.
That's crucial for moving the field forward.
Right.
It's all about democratizing access to AI, which is something we're very passionate about.
Absolutely. And how did CODESIM perform using these open source models?
The results were pretty impressive.
Yeah.
It achieved accuracy comparable to, and sometimes even better, than the results they got with the larger proprietary models.
So it's not just about the size in the model, it's about how you use it.
Uh-huh.
The clever design of CODESIM lets it kind of squeeze every ounce of potential out of these open source LLMs.
Exactly.
This has big implications for the future of AI development because it suggests that we don't always need these massive resource-hungry models to get great results.
We can do a lot with smaller, more efficient models, especially when we combine them with smart algorithms and architectures like CODESIM.
Right, and that's especially important for code generation.
It is.
We need AI systems that are fast, efficient, and accessible to everyone.
Yes.
Nobody wants to wait hours for an AI to write, a simple function.
Exactly, and that's a key aim of CODESIM, to make AI code generation more practical and user-friendly.
Now, the paper also goes into some fascinating ablation studies.
Yeah.
Experiments where they remove or tweak parts of the system to see how it affects performance.
Uh-huh.
What were some of the key takeaways from those?
One big finding was the impact of that simulation-driven approach.
Right.
They ran experiments without the simulation component in both the planning and debugging stages.
Okay.
And the results were pretty clear.
I'm guessing the performance tanked without it.
It did without simulation. CODESIM's accuracy dropped noticeably.
Okay.
That really drives home how vital simulation is
Right.
to its overall success.
Right. It's not just a cool add-on.
No.
It's essential.
Yeah, it's at the core of how this system works.
It really highlights how important it is to mimic human thinking when we're designing AI,
Uh-huh.
because we naturally use simulation to plan, solve problems, and debug.
Right.
And it looks like AI can benefit from those same techniques.
Exactly.
It makes you wonder what other human cognitive skills we could incorporate into AI systems
Yeah,
to make them even more powerful.
it's a great question.
So what else did those ablation studies reveal?
Another interesting one focused on the number of debugging attempts.
Okay.
CODESIM lets you set how many times the debugging agent tries to fix an error before giving up.
So it's like saying, okay, I've tried to fix this bug 5 times, no luck, time to rethink the whole plan.
Exactly. Did they find a sweet spot, like a balance between trying hard and knowing when to quit?
Yeah.
They did. Increasing the number of debugging attempts generally led to better results, but only up to a certain point.
Okay.
After that, more attempts didn't really help.
So there's a balance between persistence and knowing when to call in a human,
Right.
which is important to consider
Yes.
for real-world use.
We need to give the AI enough chances to correct itself,
Right.
but also know when it's better to get a human developer involved.
It's all about finding that perfect partnership between AI and humans.
It is.
Now, the paper also mentions some limitations of CODESIM,
Right.
which is always important for researchers to acknowledge.
Yes, it is.
So what are some of those limitations?
One is that it still needs a lot of computational resources.
Okay.
AI, especially these large language models, can be pretty demanding
Right.
in terms of computing power and energy use.
So while CODESIM is more efficient than some systems,
Yeah.
it's not something you can easily run on a laptop or phone.
Right, at least not yet. But as hardware gets better
Right.
and AI models become more optimized,
Yeah.
we can imagine these systems becoming available to anyone with, a basic computer.
You're hoping. What other limitations are there?
Well, like all current BI code generation systems, CODESIM is still prone to errors.
Right.
It's not perfect,
Of course.
and it can sometimes produce code that's incorrect or inefficient.
So it's still important to have human developers check the code,
Yeah.
test it thoroughly, and make sure that it meets all the requirements.
Absolutely. This highlights the need for ongoing research into AI safety and robustness.
Okay.
We need ways to make sure that AI systems, especially those that are generating code, are reliable, predictable, and aligned with our goals.
Yeah, it's all about building trust in AI.
It is.
And that takes rigorous testing, validation, and transparency.
Well said. It sounds like the researchers behind CODESIM have done a great job acknowledging these limitations
Yeah.
and highlighting areas for future research.
Right. They've laid a strong foundation for even more sophisticated and reliable AI code generation systems down the line.
They have.
This has been a fascinating deep dive into the world of AI code generation.
It has.
I'll admit I was a little bit skeptical at first,
Yeah.
but learning about CODESIM and its capabilities has really opened my eyes to the potential of this technology.
It's a field that's moving at lightning speed, and I can't wait to see what the next breakthrough will be.
If you're intrigued by what we've discussed today, definitely check out the full research paper.
Yep.
We'll link it in the show notes. And if you have any thoughts or questions about AI and coding, we'd love to hear from you.
We would.
Thanks for joining us on the deep dive.
Until next time, keep exploring.